suppose to there is a one resistor is there, that resistor is consist of one another resistor like this and one another resistor, all of these three are like this joined, and these three are joined, one another resistor of resistance is capital R, and it is going to be joined with one another resistor of resistance is this is A, and terminals are A and B. Now he is asking what is the, these three are the equal resistors supposed to be. I am going to say R, R and R. What is the supposed to be, if I am going to say the current passing through this circuit I is equal to V by 3R. The current passing through this circuit is equal to V by 3R. Then what is smaller value? What is the smaller value? If we are going to speak about this one, the current is passing like this and these three are joined at this point. That means the end positions are the same, so that this all three are in parallel. If they are in the parallel, 1 by R, 1 is equal to 1 by R plus 1 by R plus 1 by R is equal to 3 by R is equal to 1 by R1. So from this R1 is equal to R by 3. So the effective resistance for this branch is equal to R by 3 and connected with one another R. Here also one another R. This is the B end. This is capital R. Even this is also small b. So this is A. This is the one. R by 3. Now all these three are in series, so that effective resistance R effective is equal to R plus R by 3 plus capital R is equal to 2R plus R by 3. 2R plus R by 3. From this one, we know that what is the current formula? V is equal to I into R. According to this problem, V is equal to V by 3R into R effective. V by 3R into R effective. So VV is cancelled, 3R is equal to, what is the R effective value? 2R plus R by 3. So from this R by 3 is equal to R, that implies small r is equal to 3 into R. This is the simplest way. Simply this is the given circuit, the current passing through this circuit is equal to I, where I is equal to V by 3R. Then what is the smaller value? So to find out the smaller value, first you have to close this branch. All these resistors are in parallel, so that 1 by R1 is equal to 1 by R plus 1 by R plus 1 by R. You are going to get 3 by R, then R1 is equal to R by 3. Now the effective, the equivalent circuits become like this, that is equal to, this is also A end, and this is the amount of current which is passing through this one. This is the R by 3 capital R. All these three are in the series. So effective resistance is equal to R plus R by 3 plus R, then 2R plus small r by 3. But according to Ohm's law, V is equal to I into R. So I value is given, that is V by 3R into R effective. VV is cancelled, 3R is equal to 2R plus small r by 3. 3R minus 2R is equal to R by 3, then small r is equal to 3 into R. This is the value of this small r. And again we are going to discuss most important repeated type of question is the combination of capacitors and resistors is, see, supposed to be there is a one capacitor is there of capacitance is equal to 3 microfarad. It is connected with one another resistor of resistance is equal to 3 ohm, and it is also connected with one another resistor. These resistors are connected, this is the one, and this is 4 ohm resistor. They are connected like this. This branch is again connected with a 9 volt battery, and its internal resistance is 1 ohm. Is asking that what is the potential difference across the capacitor? What is the potential difference across this capacitor? Simplest way, here I am going to choose this is the current is passing. I said that in capacitor current is equal to 0, so that it is short circuited. This branch itself, it is a short circuited. Then the whatever it may be, the amount of current is passing, it passing through the 6 ohm resistor. Here junction it forms, then this current is divided into two branches, I by 2 and I by 2. Why? Because of once it is short circuited, these two are coming into series. So here also same. So series in the sense these two are of the these two are in parallel series. So effective resistance is becoming like this. This is 4 ohm resistor, even this is also 4 ohm resistor. This is connected to a battery of 9 ohm, 9 volts. This is 9 volts. This is 1 ohm. This is 6 ohms. So this is becoming into, this is equivalent resistance is becoming into, this is 6 ohm, this is 1 by 2 plus 1 by 4 plus 1 by 4 is equal to 2 by 4, which is equal to 1 by R, then R is equal to 2 ohm. Effective resistance is becoming into 2 ohm. It is connected with a battery of 9 volts and battery of internal resistance is equal to 1 ohm. So totally 6 ohm, 2 ohm, 1 ohm all are in series. 6 plus 2 plus 1 is equal to 9. Then according to Ohm's law, V is equal to I into R. V is the 9, I is the don't know, R is 9. These two cancel. Amount of current passing through this one is equal to 1 amp. Amount of current passing through this one is equal to 1 amp. Very simplest way. This is the given circuit. You want to find the potential difference across the capacitor. So the current passing through the capacitor is equal to 0. If the current passing through the capacitor is equal to 0, in the sense it is short circuited. Whatever it may be the current coming from the battery, it passes through the 6 ohms. After that it is divided into 2, so that here 3 and 1 ohm both are in the series. 3 plus 1 is equal to 4. Again this 4 and this 4 are in the parallel. So 1 by 4 plus 1 by 4 is equal to 2 by 4 is equal to 1 by R. R is equal to 2 ohm. Then so this is becoming into 2 ohm and it is connected with 1 ohm. It's the internal resistance of the battery. This 6 ohm, 2 ohm, 1 ohm, all these are in the series. 6 plus 2 plus 1 is equal to 9. V is equal to I into R, where V is equal to 9, I we do not know, this is equal to 9, whereas I is equal to 1 amp of current. I is equal to 1 amp of current is passes through this one. It means that the current passing through this one is equal to 0.5 amp, even this is also 0.5 amps of current. This is also 0.5 amps. Now once the current passed, current is calculated. So here the capacitor plate is combined between the 6 ohm resistor and 1 ohm resistor. So the potential according to this, the current passing through this is equal to 1 amp, while the current passing through this one is equal to 0.5. So V is equal to, let it be, this is V1, even this is also V2. V is equal to V1 plus V2, that is I1 R1 plus I2 R2, where I1 is equal to 1, R1 is equal to 6 plus I2 is equal to 0.5 into R2 is equal to 1 is equal to 6 plus 0.5 is equal to 6.5 volts is the potential difference across the capacitor. Potential difference across the capacitor. Here also same assumption. Current passing through the capacitor is equal to 0. This is short circuited. Then remaining current is divided into these two branches. Then this is because of 1 ohm and 3 ohm are in the series. So 1 plus 3 is equal to 4 and 4 are the equal resistors. So that current is also equally divides. Once it is equally divides, that is 0.5 amps, even this is also 0.5 amps, same amount of current is passing through this one. You need the potential difference across the capacitor. So for that one 6 ohm and 1 ohm is the responsible for the potential difference across this one. Let it be The potential across the 6 ohm is V1, across the 1 ohm is V2. Total potential is equal to V1 plus V2. The reason is the potential is a scalar. So V is equal to V1 plus V2. We know that from Ohm's law, V is equal to I into R. I1 V1 plus I2 V2. I1 R1 plus I2 R2. I1 1 R1 6 ohms plus I2 0.5 into R2 1 amp is equal to 6.6 plus 0.5 is equal to 6.5 volts is the potential difference across the given capacitor. Thank you very much.